Hi, welcome to our CompTIA Network Plus course. In this lesson, we're going to talk about use cases for modern network environments, covering the following topics such as SDN, VXLAN, Zero Trust Architecture or ZTA, SASE, Secure Access Services Edge, IAC, and IPv6 addressing. So, modern network environments are designed to facilitate efficient, scalable, and secure communication in today's dynamic technological landscape. These environments are built to adapt to evolving business requirements and the ever-changing technological landscape. Modern network environments encompass a range of technologies and concepts, including SDN, SD-WAN, VXLAN, and ZTA. So SDN, or software-defined networking. Let me put it here. Right. So it's a paradigm shift in network management that separates the control plane and the data plane. Traditionally, network devices like routers and switches had tightly coupled control and data planes, making it difficult to manage and configure networks effectively. So SDN decouples these planes, allowing for centralized control and programmability. In SDN, a central controller manages the network's configuration and policies, while the data plane devices, routers, and switches handles the data forwarding. This separation enables network administrators to programmatically define and manage network behavior, leading to greater flexibility, automation, and agility. So some examples of the SDN is OpenFlow and Cisco CCIE. That is for the data center. Now, what about SD-WAN? So SD-WAN is a network architecture approach that decouples control and forwarding planes, providing flexibility, programmability, and centralized management. It enables businesses to optimize their wide area network connections by intelligently routing traffic across multiple network paths, including Internet, MPLS, and cellular. SD-WAN offers several benefits such as improved performance and reliability, reduce costs, increase agility and flexibility, and enhanced security. Application-aware networking. It is a key feature of modern network environments that allows for intelligent traffic management based on the application needs. This approach involves identifying and classifying different applications running on the network, enabling administrators to prioritize and optimize traffic flow for specific application. By understanding the requirements of various applications, network administrators can allocate bandwidth, prioritize traffic, and implement security policies tailored to each application. This granular control ensures that critical applications receive the resources they need, while less important applications are managed to avoid impacting the overall network performance. Zero Touch Provisioning, or ZTP, is a key aspect of modern network environments that streamlines the process of deploying and configuring new network devices. This automated approach eliminates the need for manual configuration, reducing human error and significantly speeding up the deployment process. With ZTP, network devices are automatically provisioned with the necessary configurations and software upon initial connection to the network. So this eliminates the need for on-site technicians to manually configure each device, saving time and resources. Transport-agnostic networks. This is a key feature of modern network environments that enables flexibility and adaptability in network connectivity. This approach allows network devices to seamlessly connect and communicate over various underlying transport technologies such as Ethernet, Wi-Fi, cellular, and satellite. By decoupling network connectivity from specific transport technologies, transport-agnostic networks offer several benefits, including increased flexibility and adaptability, improved resilience and fault tolerance, reduced cost and complexity, and enhanced scalability and performance. Another concept is for SD-WAN and SDN, the central policy management. So central policy management is a very important aspect of modern network environments that enables administrators to enforce consistent security and access control policies across the entire network. And this approach provides a single point of control for managing network policies, simplifying configuration and ensuring compliance with security standards. So here is another concept called VXLAN, or another technology where you can do network virtualization and extend layer 2 segments over layer 3. So with VLAN, we only have a limited number of VLAN tags that can be used, but for VXLAN, we're talking about maybe 16 million different VLAN tags that we can use, right? And this is very scalable and flexible if you use it in data center networks. So how it works is that let's say you have an underlay environment, and on the control plane, you will have all of these VTEPs, or the virtual tunneling endpoint with tunnels in between, right? And you can use VXLAN to tag a specific traffic, just like in VLAN. So if you want to extend your layer 2 segment, which means it has the same IP address over a, let's say from one DC to another, you can do so with the benefit of not extending the broadcast domain, because it's running on top of a layer 3 network environment. So this is one of the cool things about VXLAN. This is already supported on a couple of networking vendors as well. Data center interconnect. It connects multiple data centers for seamless communications, right? And this interconnection allows for the sharing of resources, applications, and data across geographically dispersed location, and enabling businesses to achieve greater flexibility and resilience and efficiency. So if you have 2 data centers, let's say 1 and 2, right? Typically, you should have a data center interconnect. So let's say you have a replication traffic from one DC to another, right? You have to use the DCI. So you can replicate the traffic. So if in case this goes down, then data, or any critical information or data, will still be available on your BCP sites, which is site number 2. There's also a lot of east-west traffic, like this one, that is being shared between the 2 data centers. So DCIs, there's a lot of technologies involved. This is very important if you put up a data center network. Layer 2 encapsulation. It refers to the process of wrapping layer 2 frames in layer 3 packets. This technique is essential for extending VLANs across data centers and enabling seamless communication between devices located in 2 different physical locations. Layer 2 encapsulation simplifies the network management by allowing administrators to manage VLANs as a single entity regardless of their physical location. And this approach eliminates the need for complex configuration and routing rules, and simplifying the network operations and reducing the risk of errors. So when we talk about layer 2 encapsulation, we can associate this also to VXLAN, because VXLAN can do layer 2, extension between 2 different data centers or sites that is divided by a layer 3 network. Okay. So zero trust architecture. It's a security model that assumes no implicit trust for any user, device, or application, regardless of its location on the network. And this approach shifts the security paradigm from perimeter-based security to a more granular and context-aware approach. So ZTA continuously verifies every access request, regardless of the source, before granting access to the network resources. And this verification process involves multiple factors, including user identity, device health, application behavior, and network context. Some examples is Google Beyond Corp, which is a well-known example of a ZTA implementation. Policy-based authentication. Authentication based on predefined policies which ensures only authorized access to network resources are provided. This element implements secure access control and mechanisms such as the example of MFA implementation. The function of policy-based authentication is to ensure that only authorized users can access critical network resources by enforcing predefined access rules and security measures. Policy-based authentication can be implemented using various methods, including password-based authentication, MFA, and biometrics. And these policies can be configured to restrict access based on factors such as user identity, device type, location, and time of the day. Authorization in modern networks. As we all know, right? Authorization is the process of granting permissions to access specific resources in a network. It involves defining and enforcing access control rules that determine who can access what and under what condition. Authorization plays a crucial role in controlling access levels for different users or systems within a network, and it ensures that only authorized individuals or entities can access sensitive data and applications, enhancing security and preventing unauthorized access. Talking about the least privileged access, or LPA, it's actually a security principle that involves granting users only the access rights they need to perform their specific tasks and nothing more. So by restricting permissions to the minimum necessary, organizations can better control access to sensitive information and critical systems. The primary function of LPA access is to minimize the potential security breaches. By limiting user access rights, the risk of unauthorized access, data leaks, and other security incidents is significantly reduced. And this principle helps ensure that even if an account is compromised, the potential damage is contained and limited. So examples of least privilege is RBAC, or role-based access control. You have just-in-time access, JITA, regular access reviews, and segregation of duties. Okay. Another topic is SASE, Secure Access Service Edge, SSE, Secure Service Edge. So these two concepts or technologies represent a converged network and security service model. They integrate networking and security into a unified cloud-based service, providing comprehensive security and optimized access to applications and data regardless of user location. SASE and SSE integrates wider network capabilities with security functions such as secure web gateways, firewalls, and zero trust network access. And this convergence enables organizations to streamline their network architecture, enhance security, and improve overall network performance. Many vendors offer SASE actually and SSE, and each with unique features and capabilities like Cisco Umbrella, you got Palo Alto Networks Prisma Access, Zscaler, VMware SASE, and Fortinet FortiSASE. Okay. Another concept here, our topic is automate infrastructure as a code. It is the process of managing and provisioning computer data center through machine-readable definition files rather than physical hardware configuration or interactive configuration tools. The main function of ISE is to automate provisioning and management of the infrastructure. By defining infrastructure as code, organizations can easily track changes, roll back to previous configurations, and ensure consistency across environments. Some popular software or tools that is used in IAC is Terraform, Ansible, Chef, Puppet, CloudFormation from AWS. Okay. So automation in IAC. Here we're talking about scripts to automate network tasks, and this approach streamlines network operations and reduced intervention and deployments. Efficiency is a key benefit for automation in IAC. By automating repetitive tasks, organizations can significantly reduce the time and effort required to manage their network infrastructure. Talking about playbooks, templates, and reusable tasks. These are predefined automation scripts and templates and designed to streamline and simplify network operations. One example is Ansible playbooks, and these are very common for or a common example of reusable tasks for network device configuration. These playbooks define a series of steps for configuring network devices, ensuring consistency, and reducing the time and effort required for manual configuration. Another important topic is configuration drift and compliance. So configuration drift refers to the differences that arise between the intended configuration of a network device or system and its actual running configuration. This can occur due to various factors such as manual changes, software updates, or even unintentional errors. The primary function of configuration drift management is to ensure that network configurations remain consistent over time, and this involves identifying and addressing any discrepancies between the intended and actual configurations, preventing potential security vulnerabilities and performance issues. Automated compliance checks, right, are a common example of configuration drift management. These checks involve scanning network devices and systems for deviations from predefined configuration standards. Any kind of discrepancies are flagged and reported, allowing network administrators to take corrective actions and maintain compliance. So, automating the upgrade process for network infra through IAC streamlines and optimizes the management of network resources. This approach enables the use of code to automate and manage the lifecycle of infrastructure, ensuring consistency, reliability, and efficiency. So, implementing rolling updates with IAC tools like Terraform, Ansible allows for seamless upgrades. Like for instance, in a rolling update scenario, IAC can automate the process of updating a subset of servers in a controlled manner, testing the changes, and then progressively rolling out the updates to the remaining servers. This method ensures minimal disruption to network services and allows for quick rollback if any issues arise during the upgrade. Dynamic inventories and network management. So dynamic inventories reflect the current state of network infrastructure. They provide a real-time view of all network devices, services, and resources, ensuring that the network management tools have access to the most up-to-date information. Dynamic inventory scripts for cloud resources are commonly used to automatically update resource lists in cloud environments. These scripts can be integrated with IAC tools, providing a dynamic and accurate view of cloud resources for automated deployment and management. Source control in IAC. This is very essential for managing code versions and changes for network configurations. This practice allows for tracking changes and facilitating collaboration in network management. So by using source control systems like Git repositories, organizations can store in version network configuration files. And this enables them to track changes, revert to previous configurations, and collaborate on network deployments effectively. And finally, the last topic about IPv6 addressing. So IPv6 is a next generation IP addressing scheme designed to address limitations of the current IPv4 system. IPv6 provides a significantly larger address space compared to IPv4, enabling a vast increase in the number of network devices that can be connected to the network. The need for IPv6 arises from the growing demand for IP addresses as the number of internet-connected devices continue to increase. IPv4 address exhaustion is a major concern, and IPv6 offers a solution by providing a much larger address space. Implementing IPv6 address formats in network design involves configuring network devices and routers to support IPv6 addressing. This includes assigning IPv6 addresses to devices, configuring routing protocols for IPv6, and ensuring compatibility with existing IPv4 infrastructure. Okay? So that's the end of the lesson. Here we spoke about SDN, VXLAN, ZTA, SASE, IAC, and IPv6 addressing. Thank you very much for watching the video.